Hi guys, today we're going to determine the likelihood of an event. We learned in the previous lesson that probability tells us the likelihood that something will occur. And we can write probability either as a fraction, a decimal, or a percent. So as we see on this number line below, we're measuring probability between 0 and 1. If an event has a probability of 0, then that means that it is impossible. So say for instance, if you have a bag full of nothing but blue marbles, the probability of pulling a yellow marble would be 0. On the other hand, if an event has a probability of 1, it means that it's certain. It will definitely happen. So if I had a bag full of blue marbles, I have a 100% chance of pulling a blue marble because there's nothing in the bag except for blue. Here in the middle, if we have a 50% chance of something happening, or 0.5, it means that it's equally likely as not. So one of the examples that you'll see a lot is tossing a coin. If you have a coin and on one side there's heads and on the other side there's tails, there's an equally likely chance that you could land on heads or tails. And here in the middle, or between 0 and 1/2 is a 0.25. This means that it's 25% likely to happen, which means that this is pretty unlikely. And on the other side, we've got 0.75 or 75%, which means it's likely. Now, really, this is a continuum. That means that as you go further to the right, past 0.5, these events become more and more likely to occur until you get to 1. And as we go further to the left past 0.5, it means that the event gets more and more unlikely to occur. So let's take a look at a couple of examples. So in this first example, we want to determine what is the likelihood of rolling an even number on a fair cube. Notice that we have this number fair. As we talked about in the previous lesson, that this number fair just indicates that the chances of rolling any of the sides on this cube is equally likely to occur. So there's no chance that one is weighted heavier on one side than the other. Everything has an equally likely chance of occurring. So let's first take a look at what could happen if we roll this dice. So that's called the sample space. So I'm just going to call that capital S. And I'm going to list out all the things that could happen if I roll this number cube. I could roll a 1, I could roll a 2, a 3, a 4, a 5, or a 6. So now if I wanted to determine the likelihood of rolling an even number on this cube, then all I have to do is figure out how many even numbers there are. So 2 is even, 4 is even, and 6 is even. So if I wrote out the probability of finding an even number, I could call that P. That's the probability of rolling an even is equal to, there are 6 possible outcomes, so I'm going to put that in the denominator, and of those 6 outcomes, 3 of them are even. And again, I can write that as fraction, decimal, or percent, so I could also call that 0.5 or 50%. So if we refer back to our chart, if something has a 50% chance of happening, then that means that this is equally likely as not. Okay, let's look at the second part of the example. Here I want to determine the likelihood of rolling 5 on a fair number cube. Again, that number fair, or that word fair, just means that there's an equally likely chance of landing on any of the sides on the cube. So to determine the likelihood of rolling a 5 on this number cube, again, I'm going to find the probability of rolling a 5. So the probability of rolling a 5, again, there's 6 possible outcomes, and out of those 6 possible outcomes, only one of these numbers is a 5. So there is a 1 out of 6 chance that this could happen. And again, if I write this as a decimal, I could call this 0.167 or about 16.7% chance of this happening. Okay, let's take a look at another example. So a bag contains congruent colored marbles. There are 7 green, 10 yellow, 5 purple, and 8 red marbles. Which color marble is most likely to be chosen? Again, this word congruent just means that all of the marbles are the same shape and the same size, which gives each of the marbles an equally likely chance of being chosen. So now if I want to compare the probability of choosing any of these colors, I can do that by writing the probability of each. So let's first take a look at the probability of green, which is 7 out of, and I almost forgot, I would like to add these all up to find out what the total is, because that's going to give us our sample space. So if I add these all up, 7 plus 10 plus 5 plus 8 is going to give me a total of 30 marbles in the bag. So out of that 30 marbles, 7 of them are green. So the probability of rolling green is 7 out of 30. The probability of rolling yellow is going to be 10 out of 30. The probability of rolling purple is going to be 5 out of 30. And the probability of rolling red is going to be 8 out of 30. Now, when I'm comparing from 4 different events, I may or may not want to change these into decimals. Sometimes it may be easier to just compare the numerators. And just by looking at this example, I can see here that the most likely thing to occur is to pull a yellow, because there are more yellow marbles in the bag than any of the other colors. But if I were given a list of fractions and I wanted to compare them, then notice that each of them has a denominator of 30. So to determine which one has the highest value, we would compare the numerators. And of course, 10 is larger than 7 and 5 and 8. Therefore, the yellow marble would be most likely to be chosen. Okay, let's look at our final example. We want to look at this and determine which number is the arrow most likely to land on. Well, when I look at this spinner, I notice that there are multiple numbers, and some of the numbers are on here more than once. So let's make a list of how many of each number we have. So for the ones, we have 1 of them. For 2, if I count those up, I've got 1, 2 twos. For 3, I've got 1, 2, 3 threes. For the number 4, I have 1, 2, 2 fours. For the number 5, I have 1, 2, 3, 4 fives. And I don't seem to have any 6s. So let's first count these up and make sure that they match the same number of sectors that are on this spinner. So I've got 3, 6, 10, 12. So that's a total of 12, and I just want to double check to make sure that I have 12 sections. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So out of these 12 sectors, one of them has a 1, 2 of them have 2s, 3 of them have 3, 2 of them have 4, and 4 of them have 5. So looking at this, there's several ways that a question could be phrased. I could ask, as here, which which number is the arrow most likely to land on? In this case, since there are 4 5s that's higher than any of the other numbers, then that means that this spinner has a higher likelihood of landing on a 5. I could have also rephrased this question to ask which numbers have an equally likely chance of being landed on. And in that case, we would call it 2 and 4 because 2 and 4 both have two spaces that have the number 2 and two spaces that have the number 4. And I could also ask which two numbers have the least likelihood of being landed on, or which number has the least likelihood of being landed on, and that would be a 1 because there's only one 1. And I could even get a little tricky and ask what's the probability of landing on a 6? Well, there is no 6 on here, so of course that would be 0 probability. Okay, so just to recap, we can determine the likelihood of an event by taking a look at its probability, which is measured between 0 and 1. And the closer we get, if we're at 0, it's impossible. If it's at 1, it's certain. And if it's 0.5, it's equally likely as not. The further we get to the right past 0.5, the more likely it will happen. The further we go to the left past 0.5, the less likely it is to occur. All right, so I hope that was helpful, and let me know if you have any questions.